Hello, welcome to this presentation of International Plumbing Code water pipe sizing. My name is Thomas, and you might be wondering, where do you even find water pipe sizing? Ah, yes, it's not in any of the chapters. They kicked it to the back of the book. Join me in Appendix E, and we'll explore it all. Yes, water pipe sizing goes right along with International Plumbing Code Chapter 6, where we talk about water supply and distribution. But it's not in there, it's in the back, Appendix E. So let's discuss this. First of all, as we look at water pipe sizing, we may want to consider, what is the goal? What are we trying to accomplish if we're going to size these water pipes? What happens if the pipes are oversized? Think about this. Pipe and fittings cost money. If they're larger, they cost more money. So if you oversize it, you may be able to deliver as much water as ever needed, but maybe you're spending too much money on this thing. On the other hand, what if they're undersized? You know, back in the early days of water piping, it was all half-inch to everything, half-inch galvanized to everything, from everything. Now, if you've ever lived in a house like that, which I have, built in 1955, you easily come to find out that when you use one fixture, you lose on another fixture. You're competing for water, and it's no fun. Now, water pipe sizing can be very complex and time-consuming, so some of us come up with, general rule of thumb. How about 3/4 inch water line out to a bathroom group? But then that brings up the question, is a 1/2 inch line okay for an entire bathroom group? And when I say bathroom group, I'm talking lavatory, toilet, and tub or shower. 1/2 inch enough for all of that? Yeah, maybe. What about a soaker tub? How big do you go to a soaker tub? Do you want to run 3/4 all the way? Is 1/2 inch okay? While we're riddling here, how about a few more questions? How many bathroom groups can you put on one 3/4 inch line? If you're running a 3/4 inch distribution pipe out and you got branches off to bathroom groups, well, how far can you go with one 3/4 line? When should you use a 1 inch main line or even a service line? We talk about service versus water distribution pipe back in chapter 6. Your service line is what brings all the water in. Minimum size is 3/4 inch. Well, how do you know when you need a 1 inch or larger? Once it's inside, how do you know when you go from 1 inch to 1 1/4 if you're running a large distribution pipe? Or how far should you run a 1 inch into the building before you reduce it down to 3/4? And last but not least, what happens if you guess and guess wrong? Well, the answer to that question is, if you're wrong, you could either have expensive pipe systems, as mentioned before, or inadequate water and competition between fixtures. So, I didn't answer a lot of these questions, but in this presentation, hopefully, by the time we're done, you'll have a better idea of how you can come to those answers. Some things that we have to consider as we're looking at water pipe sizing is what of the probability of use. For example, if I have a bathroom group, what's the probability that the faucet at the lav, the toilet, and the shower are all going to be running at the same time? Well, most of the time you got a single user or so in there. Not everything's running at the same time. That might affect the pipe sizing. On the other hand, if we look at probability of use and rate of use, let's go to, a sports stadium. And we're all watching the game, and then it's halftime. And what does everyone do? Get up and go to the bathroom. Now you have hundreds of fixtures all going at the same time. So the rate of use and probability there is different. And the sizing will be different for piping and considerations for the whole system, because you get this incredible impact use all at once, whereas a lot of the time it might be sitting unused. Some of the factors that also affect sizing would be, what's the incoming pressure? Are there velocity limitations? What are the materials that we're using? And do they create a flow restriction? Well, all of them do, but how much? What about the characteristics of the water source itself? Would there be fluctuations in pressure, for example? If so, we may need to size that for the low pressure end so that we're not hurting when it goes down low. And also demand. If you're like me, the first time I attempted to size water pipe, my head was absolutely spinning. I was so frustrated. And I thought, isn't there an easier way? Well, let's look at that. An easy method would be size for continuous operation for all fixtures. That means if we size everything's going all at once, well, then I would oversize the pipes, and of course the cost would go up. Then, as mentioned before, the lazy method is to just run 1/2 inch to everything. But then you're going to have competition, user complaints, and even possibly dangerous conditions. Interesting statement here right out of Appendix E. This is in the code book. It says, because of variable conditions encountered in hydraulic design, it is impractical to specify a definite and detailed rules for sizing of the water piping system. Current sizing methods do not address the differences in probability of use and flow characteristics of fixtures between types of occupancies. That's what I was talking about. A house is going to be much different than a stadium. Creating an exact model of predicting the demand for a building is impossible. And final studies assessing the impact of water conservation on demand are not yet complete. Okay, what's happening here is the International Plumbing Code does not want to take responsibility for your failure and my failure to create a good system by the way that we size. They can't just prescribe something and say, here it is, this works for everything, because there's such a variety of uses and occupancies. So that's why they don't want to prescribe something. Interesting that they use words like impractical and impossible. They make this sound like it's kind of out there. But they do also provide several methods for us to use. Let's have a look at those. If you have not already, grab your codebook, open to Appendix E, Sizing of Water Pipe Systems. As stated earlier in the code, there are 2 methods they're going to give us. The first method is the segmented loss method. And yes, this method involves a lot of math. This is the long way. This is the difficult way. They give us an example, a table here, where we can figure out pressures and then subtract for losses for every single thing along the way. The first time I did water pipe sizing and I didn't know what I was doing, I came to this, read through it, and tried to do this. It was extremely difficult and I didn't have enough information. How was I to be able to find out the friction losses for every pipe, fitting, valve, and everything along the way? It would have taken me weeks, and I didn't have weeks to do that. Luckily, they also gave us a simpler way, the selection of pipe size. In the 2018 code, this was E201, but in the 2021 code, this is E104. This method takes us through some very basic steps. I'm going to go through this with you so that you'll be able to size pipe. Let's go to step 1. You can find step 1 is listed right there in E104.1, and it has a number 1 down there. And the first thing we do is we list the fixtures and find the water supply fixture units. What that means is I'm going to go through the whole building or branch, whatever I'm dealing with, and I'm going to list out every single fixture that is connected. Then I go to the table on E103.3, parentheses 2, which looks like this. As we examine this table from left to right, there is a list of fixtures on the left. The second column tells us about the occupancy, whether it's private or public. The third column tells us the type of supply control. Then we get into the actual water supply fixture units. Notice how they are separated into cold, that's the 4th column, hot, that's the 5th column, and a total on the 6th column there. The reason for that being, sometimes our pipe is just for cold, sometimes it's just for hot, and sometimes it's a distribution pipe that's coming in and is going to feed both cold and hot. Say it hasn't branched off for the water heater yet. We use water supply fixture units to create a value that helps us to determine what pipe size we should use. The second step is to find the system pressure. We're going to use this on a table later to help us size the pipe. Now, we've looked at a lot of factors that impact the system pressure, but in general, if you know what your system pressure is coming into the building, that's a great starting place. Or you might look at what will you set the pressure reducing valve to. Many city water systems have very high pressure, and you're going to reduce that with a pressure reducing valve. So if you decide you're going to set that at 65 psi, you know that's your starting point, and you can use that on the table. If you're on a well system, a well can fluctuate anywhere between 45 and 65 or so. You'd want to size it for the low end, go for 45 psi. If you don't know what the pressure is in that area, maybe you could go to a building nearby, next door even. Ask if you can take a quick pressure reading, and that'll help you understand where we're at. Or you may even contact the city or local jurisdiction and say, hey, what is your system set at? What can I expect in this area for a water pressure? Step 3 in water pipe sizing is to find the developed length. Developed length refers to the length of the pipe through the fittings following the center line, wherever it goes. In this case, we're going to look at the distance from the source to the very most remote fixture in the system. That's going to be our developed length. How can you find a developed length? Well, if the building isn't there yet, you could scale on a plan. That'll get you pretty close. If the building already does exist and you're there in the rough, you can pull out your measuring tape and just take measurements, add them up, and come up with a number. In step 4, we're going to take the information we gathered in the previous steps, and we are going to determine the service pipe and the main distribution pipe sizes. The service pipe is that pipe that brings water into the building, and the main distribution pipe is the large pipe that's going to go throughout the building. It's going to branch off to water heater and to other things. It's the big one. In step 4, we need to use the tables. This is table E104.1 in the 2021 code, or if you have a previous code, it's E201.1. But there are a series of tables that all kind of look the same. And to figure out which one you're going to use, first you have to consider your pressure. Right here on the table is where we have the pressure range. So you take whatever pressure you figured for the system, and you find which table matches closest to that pressure. Once you know which table you're using, then we move on to maximum developed length. We take the developed length that we calculated and come across the top row and find which column matches closest to what we're dealing with. Now you'd always want to use a column that is greater than or equal to your number. So for example, if I have a 95-foot developed length, I don't want to use the 80-foot column, I'd want to use the 100. I'm a little less than 100, but I'm in. Once I've determined which column to use, I can come down that column and I see a series of numbers. These numbers are the water supply fixture units. I calculated that when I figured up all the fixtures in the building or branch and came up with a total supply fixture unit that they would need. From there, I can come back across to the left and determine the distribution pipe size and the main pipe size. Now you may notice that some of these numbers are the same. Look at this series of 32s. There's a whole bunch of them. If I have 32 water supply fixture units or less, there's a lot of range here. In that 100 column, if I go back to the left, I could use a 3/4 inch service pipe and have a 1-inch distribution pipe. I could also use a 1-inch service pipe with a 1-inch distribution pipe, or it could also work with a 3/4 inch service pipe and a 1 1/4 inch distribution pipe. What I'm saying is that this does present a number of options for pipe sizes. This is how we use this table to determine pipe sizes. Start with the pressure, go to the maximum developed length, use your water supply fixture units, come back to the left and find your pipe size. In step 5 of the sizing process, we do the exact same thing as we did for the service and main distribution lines, but now we're just determining smaller distribution pipes. We can come right down to a branch that feeds bathroom groups or whatever. And the table is used the same. So to review, here are our steps. Step 1, find the water supply fixture units for all of the fixtures in the building. Step 2, find the system pressure. Step 3, find the developed length for the system. Step 4, use the tables to size the main lines. And step 5, use the tables to size the branches. All right, let's do an example together. Let me walk you through how we would do this for a certain list of fixtures in a building. Here we have example 1, a typical house. 1 kitchen sink, 3 bathroom sinks, 3 toilets, 2 tub showers, 1 washing machine, 2 outside hose faucets. Let's say we've done some research and determined we have a pressure of 60 psi. We've also done some research and found that we have a developed length of 65 feet. We have the information that we need in order to size this. Question: do you include the water heater in your sizing? The answer is no. The water heater is just like pipe when it comes to water pipe systems. It just passes through there. So you don't have to add anything for a water heater. Here's another question. What do you do if the fixture is not listed? Well, it says in E103.3, for fixtures not listed, the loads should be assumed by comparing the fixture to something's listed. So do your best, compare, make your guess, and you'll be fine. Let's take that list of fixtures that we have. We're going to go back to that table that has the water supply fixtures listed and figure this out. I've got them here listed on the left side, all of the fixtures that we talked about. For the kitchen faucet, we determined that we need one water supply fixture unit for the cold, one for the hot, and when they're combined, if we're looking for the main line that would deliver, 1.4. Reason being, even if that kitchen faucet is on, it's not going to give full volume to hot or cold at the same time, so we see a reduction. Lavatory faucets, we have 3 of those. Each of those is worth 0.5 water supply fixture units on the cold, times those by 3 and we get 1.5. Same with the hot. Each of those is worth 0.7 water supply fixture units. When that is combined, if we have a mix hot and cold, that distribution line would have to be valued 0.7 times 3. We're going to get 2.1 for our lavatories. Toilets, we have 3 of those. Each toilet is valued at 2.2 for the water supply fixture units. We times that by 3 and we have 6.6. Obviously in this case we have 0 hot going to the toilet, so on our main line we have the same 2.2 times 3, 6.6 water supply fixture units. Tub showers, they're each worth 1 water supply fixture units, both on the hot and the cold. So we have 2 of those and we would come to a total of 2 for the cold, 2 for the hot, and when I'm using a single-handled tub or shower valve, it's going to be 1.4 times 2, 2.8 is what that'll be valued on my main distribution line. The washer is going to be valued at 1 for cold, 1 for hot, and 1.4 on our total. Outside hose faucets, I'm going to compare that to a fixture. I didn't see it exactly on the list. Let's give it 1 each. I've got 2 of those, so 2 water supply fixture units for those. Now I can create totals. If I'm looking at my cold water distribution line, this is after we've delivered water to the water heater, I have a total of 14.1 water supply fixture units. On the hot side, I have a total of 5.5 water supply fixture units. And for the whole building, everything that's going on at the main, I've got 16.3 water supply fixture units. With the information that we've figured for example 1, we can go on to step 4 and we can calculate our water service pipe as well as our main distribution pipe. Here's what we had. The total water supply fixture units was 16.3. The pressure in the building was 60 psi. And the developed length we found was 65. We take that to our table. This table, as we select it, gives us a pressure range of 50 to 60 psi. Now I know I'm on the right table. Then I go over to developed length. I have 65 feet. That's more than the 60 column, less than the 80 column. I'm going to use the 80 column. And I have a total of 16.3 water supply fixture units. So as I follow down in the column, I'm going to be more than 2.5, more than 9.5, but less than 32. So I'm going to use one of those lines with 32. Coming back across to the left, I could use a 3/4 or a 1-inch service pipe. And I could use a 1-inch, or I may need a 1 1/4 distribution pipe. Now let's look at our distribution pipe for just the cold. Let's say we've branched off for the water heater. Now we have cold distribution total of 14.1 water supply fixture units. We have a pressure of 60 and the same developed length of 65. If I follow that, I'm staying on this table 50 to 60 psi. I come across, my developed length is the same. I'll use the 80 column. And I had 14.1. Once again, it's more than 2.5, it's more than 9.5. I'm going to be into this range of 32 water supply fixture units. Smallest I could go as I come across to the left for a distribution pipe would be a 1-inch distribution pipe for the cold side. Question here, why would they recommend a larger distribution pipe than a service pipe? If I have a 3/4 inch service pipe coming in and then have to bump it up to 1, well, that's an important thing to know. I don't know if I have a real accurate answer for that myself. I will give you what I think about this. I think that when you have static pressure in the line, it's all closed, you're going to get a volume in there. It's going to be sufficient to deliver when you have that larger distribution pipe. You would want to be aware of that, because if you size everything 3/4, just because the service pipe is 3/4, you're going to have some problems with delivery. Let's have a quick look here with example 1. At the hot distribution side, we had 5.5 water supply fixture units for the hot, same pressure, same length. We go to the table, we follow it down, we only had 5.5. This time it's more than 2.5, it's less than 9.5. I can come across to the left. My water distribution pipe for the hot side is going to be 3/4 inch. All right, let me point out that in my first example, I individually accounted for each fixture. That means for a bathroom group, I had a lav, a toilet, and a tub. But they do give us a shortcut here when it comes to a bathroom group. You can size all of those together at once. Let's do another example with that in mind. For example 2 here, let's find the service line size for a building that has this. What if it has 5 bathroom groups? Now again, that's going to be all the fixtures that you'd find in a bathroom group. 2 washers, 2 kitchen sinks, 4 outside hose faucets. Let's say maybe we're on a well system, so pressure could fluctuate. I'm going to say low end, it could be around 45 psi. Let's size according to that. And it is a larger house. I mean, come on, we got 5 bathroom groups. Developed length here, 95 feet. So here we have it on a table listed out. We've got the bathroom groups. There's 5 of those. When we look at the combined cold and hot water supply fixture units, for a bathroom group, it's 3.6. So 3.6 times 5 is 18 water supply fixture units. The washers are worth 1.4. There's 2 of those, so we have 2.8 water supply fixture units. The kitchen also worth 1.4 combined. And we have 2 of those, so we've got another 2.8 water supply fixture units. Again, outside hose faucets, they're not on the list, so we compare that to whatever else we have. We're going to give it 1 supply fixture unit. So that's a total of 4 for each of those. The total water supply fixture units for this building will be 27.6. So they're the total water supply fixture units that we will be using to size the service line and the main distribution line is 27.6. We have a pressure of 45 psi and 95 feet developed length. Let's go to the table. We're going to use that same column, 100, for developed length. We've already verified that we're on the correct table. Its pressure is between 40 and 49 psi. Let's follow that down. We had 27.6. We follow that down. That's more than 7, more than 26. It fits into the 32. If I come across to the left, I have options of either a 1-inch service line with a 1-inch distribution line, or if I have a 3/4 inch service line, I would need to go to a 1 1/4 inch distribution line. All right, let's summarize this discussion by answering this question. When are you actually going to use this? If you are a commercial plumber, you probably don't have to use this very often, unless you're an engineer. Commercial plumbers are often given plans where every pipe on the plan is already spelled out, pipe sizes are determined. Where this becomes most useful is if you are in residential and you're getting into larger buildings or custom homes and it's not determined for you what the pipe size is. Now, you know, a small house with just a couple bathroom groups, cookie cutter neighborhood houses, starter homes, you can go with 3/4 and just branch off half. That's okay. But when you start getting into larger homes, more bathroom groups, then you really need to watch and calculate. Find the pressure, find your developed length, make sure that for the number of fixtures and the distances that you're traveling, your pipe sizes are large enough to be able to meet the demands of all those fixtures. Hopefully this is helpful to you as you try and figure out the pipe sizes for water, or if you're just trying to answer state test questions, because they will likely ask you something about water pipe sizes. Now you know how to do it based on International Plumbing Code, Appendix E. I'll see you next time.